Okay, so we're going to look at this problem regarding two textbook publishing companies. So they can charge three possible prices for a given textbook. We can say that publisher one charges these prices up at the top here. Publisher two charges these three prices here. And they can choose which price they would like to charge in here. And we're given the stipulation that if there's 100 students involved and the 100 students will go with whatever option is cheaper if the two publishers are charging two different prices. So if one's charging 10 and one's charging 15, all 100 are going to go to the one that's charging the 10 in this case. We also know that if they charge the same for the textbook, that they're going to just split the customers evenly between the two of them. So for instance, if they both pay 50, then they will 50 the customers will go to the first publisher and 50 will go to the second publisher. So what we're going to do is create a payoff matrix, determine the weak dominant strategy, a dominant strategy solution if there is one, and then discuss what collusion might look like in this case here. All right, so first things for the payoff matrix, remember our payoff matrices are going to always have the same setup. We have the two players, or in this case here, the two publishers, and we have their strategies going down the side. So the publisher one can charge $10 if they want to, they can charge $25 if they want to, or they can charge $50, and publisher two can charge $15, they can charge $20, and they can charge $50. And then payoffs in this particular case are going to be how much money the companies make off of the number of customers that they have. So if, for instance, in this first situation here, if publisher one is charging $10 and publisher two is charging $15, then that means publisher one is getting all of the customers because they are charging the cheaper textbook. And because they are getting all 100 customers and each customer is spending $10, they are making $1,000 off of that, and publisher two isn't making anything. So this is 100 times 10. 100 times 10. So essentially, in all of these, we can at least say that if one publisher is charging more than the other one, we know that they're not going to get any profits in any of this case. So it's same case here, because that $10 in that one case, the publisher is charging $10 and the other publisher is charging $20. So that's actually going to be the same thing. They're getting all 100 customers. All 100 customers are charging $10, and the $10 is also cheaper than the $50 option. So that means all 10 customers are going to go to that first publisher. Right, and we really have to just do this for every single situation and just say who's charging more, and whoever's charging less, they get all the customers, or if they're charging the same, they split evenly. So in this case down here, we can see that publisher one is charging 25, publisher two is charging 15. In this case, publisher one isn't getting any of the customers because they're charging more. And publisher two is getting all 100 customers and each of them are spending $15. So they're making $15 off of that. That's going to be the same down here too, because publisher one is charging 50 in that case, and they're still 50 is more than 15. So you're going to rather spend $15 on a textbook than 50 if you were buying these. Okay. For the middle section there, we can see that the $20 option is cheaper than the $25 option. So again, player one or publisher one doesn't make any money, and publisher two makes all of the money. And in this case here, they're making $2,000 because, again, 100 customers, each of them spending $20. And then finally, we see that $25 that publisher one is charging. In that situation, it's cheaper than $50. So they are making all of the money. In that case there, every single person is spending $25 for a textbook, so 25 times 100 is 2,500. Keep going down, again, 50 and 20 now for the next option. So if publisher one charges 50, publisher two charges 20. Publisher one is charging more, so they're not making as much money. And publisher two is making $20 off of every customer, so they're making $2,000. And then the last one, every customer, so both publishers are charging $50, which means that they're splitting the customers in this case, and each textbook is charging $50. So this is essentially $50 times 50 customers. $50 times 50 customers. So these are all of our payoffs, and this is actually our payoff matrix here. So we're done. Okay, next we're going to determine a weak dominant strategy, and we're going to first look at player one. So for a weak dominant strategy, I'll go to the next page. For a weak dominant strategy, we're going to look at comparing if one strategy is better than another, regardless of what the other person plays. So we're going to start off by looking at the $10 strategy versus the $25 strategy for player one, again, publisher one. What strategy will be better regardless of what player two plays? So we can say publisher one, publisher two, publisher one payoff. And we're asking now, is $10 or is $25 better regardless of what player two plays? So is it better if they play $15? Is the $10 option or the $25 option better if player two plays $20? Is the $10 option or the $25 option better if player two plays $50? And when we say better, we mean what is going to give a higher payoff to player one. Well, we saw that in this first case, if player one plays 10 and player two plays 15, that they're making $1,000. And if player one plays 25 and player two plays 15, well, player two is actually making all of the money in that case. That's this one down here. So player one is making $1,000 or not making anything. So in that case, it's better to do the $10 option. Similarly, on the next setup, player one charges 10, player two charges 20, so they're making $1,000 in that case. Player one charges 25, player two charges 20. Again, they're making nothing in that. So again, we see that that's the better option. And then player one charges 10, player two charges 25, so they're cheaper in both of these. So in that case, it's better to play the $25 option. So there is no weak dominant strategy between 10 and 25. We cannot say that it's always better to play one or the other. And we're going to repeat these with all other combinations. So we're going to do 10 versus 100, 10 versus 100, or 10 versus 50, and then we're also going to do 25 versus 50. And we're going to see if any of these weak dominant strategies emerge. Okay, so again, same setup, player one, player one payoff, player one, publisher two payoff, or publisher one payoff. And we want to compare, again, each one of these strategies against each other. So 10 or 50, 10 or 50, 10 or 50. I'm moving kind of quickly here because you'll find that it's kind of competitive, and we're going to see how does the $10 or $50 strategy compare to the $25 strategy of publisher two or the $20 strategy. How do those two strategies of publisher one compare to publisher two? Is there some situation that is always better? And we actually see that these breakdowns are going to be very similar. The $10 option compared to the $15 option, it's going to be player one's going to actually get all the customers. In that case, they're going to make $1,000, as opposed to if they charge 50, they're not going to make anything because they're the more expensive option. So it's better to be the $10 option. The 10 versus 20, again, same thing. It's cheaper to do the $10 option compared to the 20, but the $50 option is more expensive, so they're not making all that money. And then the 10 compared to the 50, they're making 1,000 on the one side. And then in the 50-50 case, they actually split the customers, so it was better for that. So again, no weak dominant strategy there. And then we check the last one and see if there's any weak dominant strategy here. So is it better to charge 25 or 50 every time? 25 or 50 every time. 25 or 50 every time. Compared to the 15, compared to the 20, compared to the 50. Okay. If you want to try and pause it now and see if you can match up these answers, you go for it. Otherwise, we'll see that it is you're overcharging compared to the 15, so you're not making anything either way. Same thing, you're not making anything either way. And then in the 25 versus 50 option, you're actually making the same in both of these cases. So again, there is no weak dominant strategy. We see that for player one, there is no weak dominant strategy because there is no strategy that is always going to be better for player one, regardless of what player two does. Now what we can do is we then have to repeat this idea for player two and see if player two has a weak dominant strategy. And you'll see from the answer key that that's actually not the case in this case, that player two shouldn't have a weak dominant strategy. You might have one situation where maybe I think that $15 is weakly dominant compared to the $20, so it's better to do the $15 compared to the $20 every time. But there's no one strategy that they should play that's always going to be better than the other person. So in this particular problem, there actually is no weak dominant strategy. There is no weak dominant strategy for either player. And because of that, there is no dominant strategy solution. If there was a dominant strategy solution, that would mean that there's one player that has a weak dominant strategy. They're going to play that strategy every single time. And the dominant strategy solution is then saying, all right, well, if that one player is going to play the one thing every single time, as the other player, what's going to maximize their profit? What's the strategy they should do in return? The combination of those two things is the dominant strategy solution. Now, one thing you'll notice in this case here is that if both publishers charge $50, even though they are splitting the customers, they're both making more than they would at any other point in this diagram. So this is the collusion situation here. The collusion situation is saying that everyone needs a textbook, so if we charge the most and just split the customers, we're both going to make a large amount of money. There's no competition. And in this case here, it'd be problematic because there's really no incentive for anyone to try and make a cheaper textbook, because if they do, it's actually not going to be as much as if they were to just split the customers right down the middle there, knowing that everyone needs to get it. So that would be the collusion situation, is that we have one situation that it's just so far out there price-wise that if both companies decided to charge at that particular rate, then they would both make an ungodly amount of money in this situation. Now, what could be interesting is that in a real life situation, if you don't charge 25 as publisher one, maybe you just charge 40 while the other person's charging 50. Well, then you can actually get other people to jump on board. I mean, it's probably still an overpriced textbook, but that's kind of how we avoid collusion in that case, is that there's always an incentive to change strategies from someone in order to try and get a cheaper price. But in this case here, that's the collusion setup where both companies decide to just charge the most amount, knowing that they will make more money if they split the customers than if they were to try and sell at a cheaper price on their own. So that's how you would tackle a problem like this, noticing that the payoff matrices, again, is the profits of the individual customers. So how much money are you making off of the customers for selling the textbook at a certain price? There is no weak dominant strategy because no one strategy was always better than another, regardless of how the other player was going to play. And that meant that there was no dominant strategy solution. And we see that there is a collusion situation where if both companies decide to charge the highest amount and split the customers, they'll still make more than everyone else. And they'd be the only winners, not really, unfortunately, not the poor, literally poor college student in this case. So hopefully this helps you solve other problems similar to this in the class.